Example 1. A single turn of rectangular coil of size 10 by 5 cm is placed between the north and south pole of a permanent magnet. So initially the plane of the coil is parallel to the magnetic field as shown in figure 2. If the coil is turned by 90 degrees about its rotation axis, so it goes to be something like this lah. So it is now 90 degree to the 90 degree to the 90 degree to this permanent magnet lah. Okay, so the magnetic flux density is given as 1.5 Tesla. Calculate the change in magnetic flux through the coil. Okay, so make sure to not get confused between magnetic flux density and magnetic flux, because I keep mentioning it as if it's the same what do we call that, same thing lah, tapi it's not actually the same thing lah. Magnetic flux density is B, which is equal to 1.5 Tesla, and area is 0.1 times 0.05 lah. Okay, so for this one, initially this is the area. I'm just gonna directly draw it here. Actually, I'm gonna draw it bagus sikit lah. Okay, so the magnetic flux density initially, before they're gonna rotate. For example, this is our magnetic flux density, and initially the angle of the the rectangular coil is parallel to the, so it is parallel to the permanent magnet. Hence, the vector, area vector, is 90 degree to the magnetic flux density. Okay, so what does this gives us? It gives us the initial magnetic flux to be equal to 0 degree. Okay, now let's look after it is being rotated. Okay, so it is rotated 90 degree to the rotation axis. Okay, right, so this is our rectangular coil. Okay, so this is our rectangular coil, and we know that the area vector is always 90 degree to the surface. Hence, if you look at this angle, the magnetic flux density is parallel to the area vector, hence giving us the angle to be equal to 0 degree. So what does an angle 0 degree tells us is it is telling us the magnetic flux through at this point is actually at the maximum. So this is gonna be BA cos 0 degree, hence it would gives us a value of 7.5 times 10 negative 3 Weber. Okay, so after we've obtained the initial and final magnetic flux, we can then calculate the change in magnetic flux by just subtracting those two lah. Okay, so this is V final minus V initial, which gives us 7.5 times 10 negative 3 Weber juga lah. Okay, alright, so that is on our example number 1.